So here's a rather philosophical and precise study of web search, which notes that we started off in whatever it was, 4,000, 5,000 years ago with Sumerian archives, which are 25,000 clay tablets stored in temple rooms, and those were inventories and records of commercial transactions. Then we had the Great Library of Alexandria, founded 300 BC, 2,300 years ago, and it was meant to store a single copy of all the world's books, and at its height, it had a total of 750,000 scrolls. So obviously that was an early example of a modern classical library. So monks and monasteries actually did a lot of copying, and that was pretty important in preserving information, because obviously the original texts from those times were not produced in single copies, and that was an important activity. Then, of course, we had this printing press, which allowed us to make multiple copies of a document, and that, of course, that made a big difference. That was Gutenberg's great idea. If you look at today, here's a couple of these slides come from Germany, so that's why you see some German and references to Germany here. They have 25 million items in the German National Library, which is in Leipzig, Frankfurt, and Berlin. Library of Congress, which tries to keep everything, is the world's largest library. It has its own classification scheme, which is sort of a keyword-based scheme, and it has 150 million items, with 20 million, which is actually the size of the German library roughly, added since 2009, and that's in a couple of years, because these slides are from 2011. So here is the type of information actually you'll see in the Dublin core, which is the author and the editor and things like that. This is a very important concept called metadata. This is data about data. This tells you broad information about books. That is very important. Books are sufficiently modest in number that it is realistic to keep that, make that metadata. On the other hand, the metadata doesn't tell you enough if you want to do a general query. It could have keywords, but I pointed out the deficiency of keywords, that the keywords are done by the eye of the keyword, in the mind of the keyword, and that they may not capture ideas that come along later and things like that. So keywords, I think, are going down in importance, as I said earlier. So we can use catalog cards, but they will not, I don't think, although you can view them as document proxies, and as a sort of summary of a document, but I don't think that if you use the catalog cards, you get the right answer. And the huge advantage of text search, as it says here, is that every word is a keyword. And given that we have computers which are capable of processing all the words in the document, I think there's little doubt that full text search is the best approach. Full text searches did exist. I'd forgotten this. And before computers came along, they were called concordances. They were only a listing of the principal words used in the book, and they were only done, of course, for a few books, such as the Bible, which was first done with 500 monks. Good example of parallel computing in the year 1250. So the web came along in 91. There were early web search engines. Excite was one of the more modern ones with full text search. And web search and information retrieval were pretty similar until '98, and then Google in '98 had this very significant, important discovery that by looking at the link structure and using the so-called PageRank algorithm, you could greatly improve the relevance of results. So if you look at what a document is hopefully a coherent passage, namely it's a set of words, which words are all connected by some theme, but they're written in some free-form fashion, which the language supports. And of course, documents vary from a web page, through a book, through a Wikipedia entry, from an email, article in a newspaper, etc. All sorts of units of documents. Documents can be collected together in the academic field of information retrieval. That's usually called a corpus. And you try to make corpuses which are similar. And the web is full web is a corpus. Medline, a system from NIH, is a corpus. And when you look at a particular output from Google News, that's also a corpus. That's a dynamic corpus created by Google from surveying lots of documents according to various criteria, which are trying to find related documents. So when you do a web search, it's assumed that you're asking for information, and that is the topic. And you're not asking for the word semantic web, as we illustrated earlier. You're interested in the topic semantic web. That's actually not always true. Sometimes you know the words are present in a document, and you actually do not want the topic semantic web. You want the word semantic web. And this is all a little fuzzy because it relates to the individual's mind. And when he writes down something, he or she, I should just write down something, and any one individual may mean a different thing by those same words. And so you need to also bear that in mind, that you need to give responses that cater to particular users. Of course, modern search engines, like if you take the Google search engine and the Microsoft search engine, they're embedded in your Google and Microsoft environment. And those Google and Microsoft environment know all sorts of information about you from your previous queries and things like that. It points out that at some level, information retrieval is ill-defined, even if it has no precise mathematical answer. It has an operationally correct answer. The answer is trying to make the user as happy as possible. Remember, the world is full of optimization problems. The optimization problem solved by web search is returning the best possible set of documents to answer what the user intended to imply by his search. And of course, I deliberately said intended to point out it was pretty vague. So the query is actually what the user writes down. It is usually just a list of search terms like semantic web. Of course, it can be made. You can use this formal query language, but as we noted, most people do not use query languages. So here you're trying to find the word panda near the word jaguar, but you do not want the word animal near panda. So this is this formulation of this optimization problem, how we quantify what the user really wanted. And so, and how do you think we find that out? Well, obviously we do surveys. We see if the user returns to the same search engine. If the query is something to do with buying something, then I type a query called Nike shoes. I maybe want to buy Nike shoes, and so they can tell whether they sent back the right result by whether I go and click through and buy something.